A pleasant greetings to all. In this video, I am going to explain Thevenin's theorem. Before we see the Thevenin's theorem, first of all, we should know what are the theorems available in network analysis. The theorem number 1, Thevenin's theorem, number 2, Norton's theorem, 3, superposition theorem, number 4, maximum power transfer theorem, number 5, reciprocity theorem, 6, compensation theorem, 7, Millman's theorem, and 8, diligence theorem. These are the important theorem that is used in network analysis. First of all, we are going to see Thevenin's theorem. What is the statement for Thevenin's theorem? In a linear, bilateral, active network consists of more than one voltage source, more than one current source, and then more than one resistance can be replaced by a single equivalent circuit consists of voltage source, that is VTH, in series with the resistance RTH. The VTH or VOC is Thevenin's voltage source and RTH is Thevenin's resistance. Now how to draw the equivalent circuit? So equivalent circuit is known as Thevenin's equivalent circuit. So VTH is a Thevenin's voltage that is in series with RTH. Suppose we are having load element means we have to connect the load element across the terminals A and B. Now I am going to explain Thevenin's theorem using one problem. Find the current flowing through 1 ohm resistor using Thevenin's theorem. Okay, in this theorem that consists of current source and voltage source. Here our aim is to find out the current flowing through 1 ohm resistor. What is the step number 1? The element in which we are going to find out the current is considered as a load element or load resistance. And here what is the load resistance? 1 ohm is the load resistance. Across the load resistance you have to mark the terminals A and B. What is the step number 2? Step number 2, remove the load resistance. Now the load resistance is removed here. And between the terminals we are going to find out VOC or VThevenin. Both are equal. Now what I have to do? First of all, I have to mark the node here. This is VOC. Next I have to assume the direction of current. All the currents are flowing away from the junction. Here I am going to apply the nodal analysis. So how to write the equation using nodal analysis? Nodal analysis. So first of all, see this direction. Here this is the direction of current away from the junction, here towards the junction. So both the currents are opposing with each other. So here you have to take -2. Then see here also the direction of the current. Here both the currents are opposing with each other. So how to write this? B minus 10 divided by 10. And for this 5 ohm, the same current is flowing. And what about the voltage VOC, current, that is VOC divided by 5. Here also you have to put VOC. So that is equal to 0. Next what I have to do, I have to separate the VOC. So VOC 1 by 10 plus 1 by 5, that is equal to what? Here plus 2, here minus 10 by 10, that is 10 by 10, 1. Okay, now I have to take the LCM here. So VOC, the LCM is 10. So here 2 and here 1. Here also 3. Now both the 3 get cancelled and VOC is what? VOC is 10 volt. Now we got the answer for VOC. It is otherwise known as Thevenin. So Thevenin also 10 volt. So after getting the Thevenin, what I have to do? Step number 4. So step number 4 is what? To find Thevenin. So to find the Thevenin, first of all, deactivate the current and voltage source. Deactivate the current source. Deactivate the current source. So how to deactivate the current source? By open circuiting it. If you open circuit any terminal, is there any current flow? That is no current flow. So deactivate the current source and deactivate the voltage source. Deactivate the voltage source. So how to deactivate the voltage source? By short circuiting it. If we short circuit the voltage source, is there any voltage is there? Current is flowing but voltage is zero. Now I have to redraw the circuit diagram after opening and shorting the circuit. Here this is open circuit instead of current, and here instead of voltage source I am going to short circuit this, and then this is the short circuit path. So voltage source is short circuited. Here 5 ohm resistance is connected in parallel, and here what is the voltage? AB, and AB means that is VAB. Okay, now what I have to do? Here the resistance, here the resistance. How to find out RTH? Here we are going to find out RThevenin. So how to find out RThevenin? RThevenin is equal to, here the resistance 5 ohm, here the resistance 10 ohm. Now multiply, that is 5 into 10 divided by 5 plus 10. So that is equal to what? That is 50 divided by 15. So 50 divided by 15, that is 10 by 3 or 3.33 ohm. Okay, now RTH is over. Now RTH is over and also VOC is over. So after finishing this, what we have to do, we have to draw the equivalent now. So now what is the equivalent? Thevenin's equivalent. So voltage source in series with the resistance. So voltage source is here, and that is a Thevenin's voltage source, that is 10 volt. And the resistance is what? The resistance is Thevenin's resistance, that is equal to 3.3 ohm. We have to connect this resistance in series with RL. So what is RL? RL equal to 1 ohm. Now I am going to find out the current flowing through RL. So I1 ohm, that is equal to the net voltage, total voltage divided by 3.33 plus 1. So the answer is 10 divided by 4.33. The answer is 2.31 volt, ampere. So this is the answer. Thank you. Have a nice day.